G'day guys, and welcome back to the channel and to what's on Baz's bench. One of these, my all-time favourites, electric fences. Have lots to do with these in the past, so this one apparently doesn't work. It's 240 volt. It's our high voltage terminals. Don't muck around with these if you don't know what you're doing, because that'll give you a nasty kick. Okay, so unless you've got the gear to check these, don't bother with them. Okay, so there we go. There's his model. It's an OB 10762 and draws 2 watts. Not a lot, but there's all the information. It's made in New Zealand, in Hamilton. Okay, so been a few spiders in here by the look of it. Could be the problem because spider webs get in there, get moist, things short out. So yeah, let's give him a bit of a brush over, clean up, and we'll see what's inside. And I thought, well, we better have a look at this before we plug it in. I don't, it's not sort of like a radio. Okay, there we go. No spiders, which is good. Now, this is an electronic one. We've got a coil here, which probably won't be the problem. We've got capacitor in there, which could be the problem. And we've got our board and connectors, which could be a problem somewhere. Okay, first thing, we've got a fuse there. Let's see if that's any good. To start with, fuse is okay. That's a bummer, isn't it? So, what else? Just looking at this device, we've got an SCR or something there, or a triac. I'm not real sure what that one is. Gate anode cathode, so it looks like an SCR. The rest of it is pretty straightforward. Could be connections in there to the transformer. All this board just plugs into everything actually. So yeah, it could be a connection. I'm not real sure. Okay, there's nothing in there that's jumping out. Put it on the dim bulb, of course, and let's see what happens. Okay, on the dim bulb, turn him on, and are we drawing any current? We're drawing absolutely nothing. Right, we don't have any flash of the neons there, so nothing's happening at all in here. Do we have AC voltage? Let's check our AC. Now our AC is between those 2 points there. Let's see. And yes, we've got 230 volts, as you can see there. 230 there, 230 there. So something, somewhere, is sort of not playing ball. I think the next trick, unplug him of course, is to remove our board. And there's some connectors up the front there, and this board should pull off them. And he certainly doesn't want to pull off them. We're getting there. Well, at least all those were making pretty good contact. Okay, Look under the board. Nothing obvious. No big burn marks. Nothing very obvious there. We'll check the transformer first. Ohms. The primary of the transformer, there to there, 0.8. Secondary, 14.4. That reads okay. Now, transformer definitely reads okay. So the problem will be on our main board. Let's take a closer look. Right, now you never ever seem to get schematics with these things. It's something you've just got to try and work out yourself. Bit of shininess off the motherboard there, but anyway, not the best I can get it. So our power comes in here, goes through the fuse, and possibly through the resistor. So let's have a look, see here. Can we see anything obvious? Nothing very obvious on there. Okay, could be the SCR failed, but I'm just surveying the situation here to see, well, what is it? There's a 56 ohm resistor there. Let's just check a couple of very basic things to start with. Okay. 56 ohm, pretty close. And 100 ohm, spot on. So we know they're okay. This one is a 470k resistor. And it's just a matter of well, it's reading open, actually. That could be a feed resistor for our power. This one here is the same, a 470k, and he's reading what? 468. Go back to this one. And that little fella, believe it or not, is reading open, unless it's a cap discharging there. We'll just see what he goes down to. It could be this capacitor that's discharging, giving us a false reading. But I doubt it because that appears to be open. Okay. Well, check a couple of diodes while we're doing this. Diode here. And this circuit board has lacquer on it to stop moisture ingress. So yeah, a little bit hard to check things on this. This one, we've got a junction there, junction there. Come back to this fella. Yep, junction there. A couple of diodes up here. Junction there. Junction there. Okay. The only thing strange that we've got so far on the whole thing is this resistor here. Now that's a 470k. Let's see. He runs down here, and that's G2 the transformer. One leg of the transformer comes through this resistor up under the cap here somewhere. Got a couple of very heavy resistors there, probably, I don't know what they are, 10k, they'd be close to 10 watt resistors, I suppose, 8 watts, something like that. That cap, he's in and tight. Guys, I think I'm a bit curious about this resistor here, because it does feed our transformer, and there's some sort of, well, it goes through that cap up to here, to the coil or choke or whatever that is. I'd say it's a little choke over to here, and then he sort of disappears to here. And yeah, I'm still very suspicious. Let's lift him up and see, and then we'll also do an ESR check on the cap. Let's check him. It's probably going to make a liar out of me. Get you guys in there, see what's going on, plus a whole heap of reflection. Okay, there to there. And that's close to 470k. Yet he wouldn't read in the circuit. Okay, well, we know it's not that. What is the cap? It's a 220 mic at 25 volts. And I think I'll, he's in there. I think I'll take him out and we'll test him. Electrodes in something like this often give lots of problems. Well, in everything, isn't it? Okay. Positive is already marked. Righto. Looks okay. See what he measures. My chair does a bit of squeaking in the background there. Okay, what's he measure? 218. That's not bad. As far as ESR, I reckon he'll be pretty damn close. Let's get our little tester out. Okay, let's see what he measures and his ESR. .206 and his ESR is 0.3. So yeah, there's nothing wrong with that cap. We're barking up the wrong tree again, guys. And my customer definitely wants this one fixed up. So we have to find what's going on. Okay. What else have we got here? There's not a lot. We've got a safety cap across our mains. We've got this fella here, which is, it looks in line with the mains to maybe supply some voltage. Yeah, these are 10k each. Well, I suppose we just check them just to make sure. 5k, they're parallel actually. And it wouldn't read 5k if two 10ks were parallel. Okay, down here we've got 47 and a 0, so 470 ohm. Let's see what he measures. And right, this is very hard because of the lacquer on the board. Okay, but according to this, it's measuring open from, okay, over there to there. That's not reading 470 ohm. Now, what we're looking at is R15, okay, 4, 7, and it's brown, so that is 10, so 470 ohm. All right, there's my phone. And let's lift one side of him because he's measuring wrong as well. We'll just lift him up and see what we can find. We'll see what he measures. It's probably one of these resistors, which is a feed resistor to the rest of the circuitry, and it's open circuit somehow. And that is open circuit. That is definitely. That resistor there is open circuit. R15 comes from our ground, our neon, comes back over to here through these fellas, which is probably a ground we turn from the, yeah, it's a little bit hard without the circuit. No, it goes to that diode, which then goes back to the cap, which then goes to a resistor and drives the neon. Okay. Okay, so it goes onto there. This one connects to one side of the high voltage of your transformer. Oh, sorry, you didn't see that. I'm mucking around here. This one here, that side of the resistor, connects to one side of your high tension winding of your transformer, and it actually is a path to ground. So if the transformer is not grounded on one side, well, of course it's not going to work. And it all seems to happen from there up to there, which is Earth. Okay, let's have more of a look at this resistor, and we'll work out just what's going on. Okay, ohms. We're on ohms. There we go. And that's just me touching it, actually. Yeah, that resistor's open circuit. So I dare say we found the problem. Okay, so the resistor looks like maybe a 2 watt. 470. That looks brown to me. I can't see it being any other colour. The resistor is definitely open. Let's get a 470 ohm. I may have to go a little bit bigger because I don't know whether I've got any really small ones. But anyway, with it being more or less the return for the high voltage here. It's probably it. And as I said, this is to show you guys you can fix these, but it's a matter of trial and error with what you work out with them. Diagrams are just impossible to find. You will not find a circuit for this. So yeah, we'll try that. We'll keep that fella up off the board there a bit and put him back in, and I reckon it might work. Okay guys, here we go. I found 470 now for the newbies. Yeah, there you go. 470. That's for our guys out there that are learning. Now, I've got to learn where this come from. Okay, over here. And we might leave him just above the board a bit because that resistor may have run hot. We don't know. Maybe it's just a point of failure. Let's solder him in. Put our board back in. And guys, I reckon we've found a fault. We found something wrong. So that's a good start. As I said, this is just an informative video of what you guys you can fix if you come across something like this, especially in the farm technology side of things these days. Well, farm, equine, like there's certainly lots of horses these days have electric fences to keep them contained. How are we looking there? Looks good. Okay, we'll put this back in, and when we start it, we should see activity on this neon. Should. If it's R15. Okay. All right. Well, guys, let's plug it in and see how it goes. And of course, through the dim bulb, but we should see some activity on that. Well, I think I called it an LED earlier on. It's a little neon. It's a neon lamp, and so is this one. That one will be orange. This one, I would say, would be green, and that, yeah, don't know. That should have lit up earlier. It didn't. So maybe there's something else wrong. We don't know. I don't have to show you the dim bulb on this, do I? No. You know what a dim bulb does. All right. We'll plug him in, turn him on, and nothing. Are we drawing any power? We're drawing 0 watts. Probably wouldn't register on it anyway. Well, we should have a tick tick, but we don't. Okay. Okay, guys. Well, it still doesn't want to play ball, so I've released this cap in order to get to unsolder our SCR. There doesn't appear there's nothing else on this board. So let's have a look at the SCR and see what it measures. We'll use our trusty little metering device. And let's see what he says. If I can get my camera set up there. Okay. There we go. So I go any lead to any lead, and that should give us, I think, an SCR on this thing. We'll measure the same as a transistor, basically. Okay. Oh. Okay, between 1 and 3 is 82 ohm. Now that's between gate and anode, and between the cathode and anode is 780 ohm. Now, that to me is exactly what it says. It's a resistor. Okay, what is it? What is it? It is, if I can read it, where can we get the light on it? Don't think I can get the light on this one. I'll put it under my Maggie lamp. Just a minute here. It is a 2N6509. 2N6509. It's an SCR. Now I've got to see, can I round up one of them? Hopefully there's one here somewhere. Okay, now it's find the equivalent. SCRs, and yeah, I got a few here. Now, what is what? SP6M. No, it's not one of those. And it's not one of those. I wonder what these fellas are. I must have these for something or other. Okay. It's a TYN816. Okay, let's have a look at a spec sheet on a TYN816. Well, guys, just looking at this, he's more or less an equivalent for it. It's 800 volt, 16 amp, and this fella is the same specs, 800 volt, 16 amp. So I think the pinout is the same. I think we'll put this fella in and see what happens. Now, I've just got to twist his leads on the side to bring him out a bit, like so. Okay, he goes in with a heat sink at the back. You can see on the board, it shows you where it is. And this is Q2, by the way. Now, I did run the meter over this little fella here, and he seems okay, but this one was a little bit sus when I, put the meter on it, and rightly so. Now, this isn't, yes, no, they're both non-insulated. It's right, forget I said that. Okay, here we go. Hopefully, this will fix him up. That's what I thought about the resistor, but the resistor is possibly burnt out because it got copped with, I don't know, full voltage from this being shorted out or something like that. Maybe. We don't really know. Anyway, we'll try this. Now, I've got to put another tie around there and hold him in. I'll be right back. Right, that's it. He appears to be pushed on. Everything's right. So, Is this going to work? It will do if I can put my microphone back on, won't it? Okay, here we go again. Second time lucky. Okay, here we go. We've plugged in. We're on dim. Turn him on. And we've got a green light. And we have pulsing. We're away, guys. That's him. I'll just turn the lights off there a bit so you can see what's going on. There you go. Well, I'll just move this other light away a bit so it's not so bright and you can see the pulsing there. Okay, output. Well, let's have a look. Now, don't do this at home. I'm going to use a very well insulated screwdriver and just see what we've got between our earth point and our live. And we haven't. Yep, there we go. Here we go, guys. We got some flashing there, and I wouldn't like that getting hold of me. Okay, so working quite nicely. Take this down a bit so you can see the action. Okay, ground and 2+. There we go. Quite a nice arc. So that's good. And as you can see, our little neons are doing what they should do. Okay, guys, let's get it together. There we go. Obrien's reliable electric fence products. Now, as you saw, there's the details on it. You saw this earlier, and she's a goer. So that's what was on the bench today. If you liked the video, subscribe to me so you can follow heaps of these, and you might learn how to fix these things, because there's a lot of these around in Australia, well, worldwide really, and they're very expensive to go and just buy another one when they stuff up. All right, guys, if you liked it, give us a thumbs up. As I said, subscribe if you can, helps the channel. And with this one, that's what fixed him up, a resistor and an SCR. So we'll catch you on the next one. Okay, bye for now.